To control the air quality in a premises can be a very simple or very complex task, while in a commercial environment you can use a basic air handling unit. In a pharmaceutical industry, you must have a scientific approach. Unlike in the commercial area, the pharmaceutical industry is more demanding when we're talking about the air quality control. There are things we have to consider when we design an air handling unit that supplies air into this premises designed for production of pharmaceutical product. So we have to make sure that we're controlling the change rates, the pressure cascades, the temperature, and the relative humidity. To be able to do this, we have to use very specialized equipment, building management control, programmable logic controls, HMIs, SCADA system. So we have to monitor and to train the data for further analysis. The programmable logic control you'll see in this picture will control the equipment like variable speed drivers, actuators, and although it is very important when you make a choice to make sure that your system has got a lot of redundancy and it is very reliable. So what you'll see in this picture, it is the way we choose to wire an electrical system that provide power to a variable speed driver to make sure we have the appropriate redundancy and we run the system safely. To be able to control the airflow, we are using variable speed drivers which controls the fan motor speed. These variable speed drivers takes instruction from the programmable logic controllers, and we also use human machine interface. We call them HMIs. You will be able to see on the HMI how the motor is running. You can adjust the speed, you can adjust the airflow, and things will go a little bit more complicated, but at this stage I want to stop here. To control the temperature and humidity, we use valves that allows the cooling or heating agent to pass by and to heat or to cool a heat exchanger. These actuators which are controlling the valves get instructions from a programmable logic controller, from a thermostat, or from a building management control. But as I said before, a good control is not always enough. When we choose a heating strategy, we have to consider the heat exchanger size. I just said the actuators will only control the flow. An air handling unit is controlled by a programmable logic controller or by a building management control, or sometime only by thermostats and switches. Some technicians have very bad habits and they interfere with the control. They make a redundant part of the control and they put the system on manual mode. By doing that, you make a huge mistake, because as you'll see in this little video, the control is scanning very fast the function of an air handling unit, and it takes the appropriate decision, taking action by activating dampers or manipulating actuators accordingly to the demands. The programmable logic control or the building management control gets instructions from the probes that are fitted into this air handling unit, which collects data. The relative humidity, the temperature, the air volume, and the air pressure are collected by these probes, and they send straight to the programmable logic control, and the programmable logic control is compare the data against the software, and then it's acting on dampers or actuators. In this picture you will see a very poor design. An air handling unit provides air to a group of 4 rooms, but this ducted system is not provided with a CAV or with a variable air valves, although we do not have reheaters. So we have a global airflow measurements at the origin where the air handling unit is pushing the air into these rooms. So I do not have any chance to heat or to cool the rooms separately. The global air will be sharing between these rooms, and if I need different temperatures in each room, that will not be possible. This is a perfect example of a poor design system. Looking into the system, what you'll observe, the system, it is not provided with constant air volume, with variable air valves, with reheater, or with pre-coolers. This system provides air to 4 individual rooms. Each of these rooms are using different temperature, and they have to have the same relative humidity between 40% and 60%. Now, probably in the beginning, these rooms, they were perfect calculated with a heat load to match the airflow, and the system works well. But under this situation, if any modification has been done to these rooms, like bringing more equipment or changing the way it works, will create a big hassle in technicians' world, because this AHU will only allow me to adjust the temperature of the main airflow at the origin. So you will see these 2 probes which change their colors between red and white. One, it is the supply air on the right hand side, and the one on the left hand side, it is the return air. The return air will read the temperature of the entire return air. It will read the temperature of all 4 rooms in the same time, a kind of average, and you wouldn't know what room need more or less, and you will adjust the airflow temperature as per that average reading. So if the room has been calculated and the AHU has been designed for the room to run with a specific heat load, and somebody changed the heat load of the room without telling the HVAC engineer, the HVAC engineer will have a nightmare, because some of the rooms will get very cold, some of the rooms will get very hot, and can you imagine if the left hand side room will be very hot and the right hand side room will be very cold? If you try to increase the temperature of the right hand side room, which is 104, the room P100 will get hotter. So you either way have one room will go below the temperature, or another room will go above the temperature, and the engineer can only adjust the temperature of the global airflow, and this is a nightmare. It's almost impossible. You can only choose the middle point to satisfy the rooms which are reaching the higher and the lower alarm set point, and this is a very bad design. Also, you cannot play with air volume, because you have to have control air change rates and the pressure cascade. Otherwise you will create all kind of problem into this pressure cascades, and if the air migrates in the wrong direction, you'll have different type of problems. So when you work in a pharmaceutical industry, the design should be very, very, very well done. Otherwise the technician will have a nightmare. So this was the part 1. Please watch if you want the part 2. I'm going to talk about absolute humidity, relative humidity, how can you control the humidity, the icing up contamination, which reduce the air, and the defrost system, which if is incorrectly designed can create all kind of hassle. Thank you.